Hello, Brandon and Bailey. We're looking at our Monday edition of STAT, and it turns out that I was employed by the zoo this weekend, and I designed an experiment where I took 200 flamingos who they wanted to grow faster, and I gave them new feed, and I decided to weigh them in 2 months. And everyone said that was a rotten experiment, so they rewrote it for me. And they said, we'll take the 200 flamingos and with a random assignment, put them in one group with 100 and one group with 100. Give 100 one new feed, the second group the old feed, and compare them in 2 months. So that one showed much more intelligence in design because it had randomization, it had a control group, and there was a comparative step. So from that, however, I dropped this bomb. They told me that male flamingos grow quicker than females. So I said, does that matter? Because we put them randomly into 2 groups. And the answer is it still matters because you could have a whole lot of more males in one than the other. So today we're going to learn what to do when that happens. So if you would, then on the handout, can you show them the handout? On just the front right now. The handout, if you could start writing your notes, it's this statement on the top of the board. It's control what you can, blank, that's what we're learning today, what you can't control, and randomize to create comparable groups with replication. That's a word we forgot to mention. It's one of the 3 requirements of an experiment. Do you recall what replication meant? What was it?
A big enough sample size?
Yeah, you wanted your sample large. And these were large groups, 100 flamingos. Again, it's sort of how large is large. In the setting, just be as large as you can. So that's all they had was 100 flamingos. So replication, we already met that word. So the question is, what goes in the blank today? Control what you can, blank what you can't control, and randomize to create comparable groups with replication. So we're used to all those other words, but what goes in the blank? All right, I'm going to give myself some board space, and we will see.
Psst, we're writing on desks.
Where is Bailey?
College visit.
And where?
Wayne's Green.
Is that where Morgan is? Is anyone else we know there?
Bailey.
I know, but any other previous students?
No.
Okay. All right.
NCCS alumni. Other than
All right, so this is the moral of the story up here. Oops, I don't want this part. And we're going to build toward filling in that blank in a moment or two. So let's go back to time when a population had individuals that were similar to one another. When did we do that? We did that when we did grades. If we split them into grades like grade 9, grade 10, grade 11, and grade 12. When a population has groups of individuals that are like each other, but different groups are differing from one another, what kind of randomization did we use? Do you recall what that word was? Yes.
Stratified?
Stratified. So it's sort of, we've hit this again because we have groups of flamingos, a big group of 200 flamingos, but part of them are male, part of them are female. So we want a stratified random sample, but we're not talking about random samples now, we're talking about experiments. So we take a new look at this, but it's similar thinking. So take a note of that. When a population has individuals that are similar to each other, but differ group by group. Like in our case, the males in the flamingos and the females in the school, it would be 9th graders, 10th graders, 11th, and 12th. We use the stratified random sample. Similarly with experiments, so when we're all caught up, I'll fill it in. We use, and I'll tell you the word. So once you write that down, I'll tell you the word. It's the same word that goes up here. Can you think of any word that would make sense up here? Control what you can, blank what you can't control.
Observe.
Observe. Because somehow we want to take that aspect that we can't control and somehow deal with it, not just observe it. We want to do something to it. Any ideas at all? It's kind of hard to think of. So when a population has individuals that are similar to each other but differ group by group, we use stratified random sample. Similarly with experiments, we use blocking. So we want to block out here, we want to block out, or we'll just call it block. But you can think of it as block out. Block what you can't control. So I'm going to teach today an experiment, an aspect of experiment called blocking. So let's have an example. I guess I teach it by example. Suppose that I have a bunch of objects like cloths, like scarves. So I have a bunch of scarves, and they only are hand washable. Did you hate that? They're hand washable, and I bought how does the story go? Let me see if I wrote it down. Hand washable, new detergent. Oh, I know. I want to know if it works better, the detergent works better in cold or warm water. Now, statisticians, they want to know everything. So, say I had a scarf. I pulled out a scarf here. So, this one you can't even wash by hand. It says dry cleaning only. Why? I'm going to do it by hand. So anyway, maybe I'm ready to do it now. So anyhow, hand wash, and I want to know, should I use the warm or the cold water with this new detergent? What's it work better in? So you would think I would take all my hand washables and wash them in the cold, hang them up to dry, and then observe the cleanliness, say on a scale from 0 to 10, 10 being the most clean. Then I take them another day and wash them in the warm water, hang them up to dry, and reevaluate and compare. However, there is another aspect of it, and that is the fact lurking in this experiment is, did you know that light-colored fabrics wash better in warm water? Did you know that? In the olden days, moms spent a lot of time separating dark clothes from white clothes. Do they even do that anymore?
I don't. It's actually a complete waste of time.
And when you have the light clothes, you wash them at a higher temperature because they wash well in a high temperature. So the lurking variable is that some just because of their color, the light color, this is the lightest I could find, it's not very light. But if you had white and cream and pale yellow, those colors are going to work better in the warm water anyway. So this is an aspect that we want to control by blocking. So here's what we do. I'll do a design for this. So I have my laundries in 2 piles. And I'm going to make 2 piles. One is light scarves or light clothes.
Is this going on the tables or on our paper?
And one is dark clothes. So has there been any randomness yet? So far there's no randomness. I just take out my hand washables and I divide them between light and dark. So this is called a block, and this is called a block. So I have now developed 2 blocks. Here comes the step that you insist on, the randomization. random assignment on each block. See if you can finish the experimental design. Here, I'm writing it in between these two lines. So far I took the clothes, I divided them into two piles, each I call a block. The light clothes are in one block, and the dark clothes are in another. Now I'm ready to go random. Can you finish the experimental design? All right, did you come up here on the first block where they're light? And did you create a situation where these were washed in warm? Part were washed in warm and part were washed in cold. Perhaps you did it like this. You did group 1, group 2, and then you did washed in warm, washed in cold, and finally, did you compare the results? That was just with block 1. That was all with the light colored clothes. Do we not have to do the same for the darks? So I guess we could call this group number 3 and group number 4. Do warm and cold, and then compare. So that's called blocking. Yes.
At a time.
Time? All right, shut it down.